3.6 in your notes, which is the extension material on last lesson's work. So if you remember last day we were doing some reflections, so you were either given the reflection line or you had to draw it in and then you had to reflect the shape. So questions like this are ones where they give you the original shape and they also give you the reflection, and you have to figure out where the reflection line actually is. So there's a couple of things that I want to point out just before we start doing this. In any transformation topic or anything like that, you'll notice that they use this terminology. So a letter by itself will always refer to the original shape, and a letter with a dash after it is the new version of the shape. So in this case, A is our original shape and A dash is A after it has been reflected. Okay, and that's the case no matter what type of transformation it is that we're doing. Okay, the other thing I wanted to point out was that questions will often be worded like this, so to describe a transformation, and whenever you're doing that, because there's lots of different types of transformations, you have to say what type it is. So far all we've looked at is reflections. So whenever we would be describing our transformation, we would describe it as a transformation, and then we would say where it has been reflected about. Okay, so that's up at the top here. Whenever you're describing a reflection, you must give the name of the transformation, which in this case is reflection, and then the equation of the line in which the reflection takes place. So an example of a description would be something like this. It would be a reflection in the line of x equals 3, but that doesn't refer to anything on this page in particular. That's just an example of how you would word your description of the transformation. Okay, so let's look at this example. Describe the transformation fully that maps A to A dash. Now, the easiest way for doing this, well, first of all, I hope you can see that it is a reflection because it is a reflected shape. So once you've figured out that it is a reflection, then the easiest way I reckon is to count the squares in between two consecutive points. So consecutive probably wasn't the right word to use. They're two corresponding points. So if you can see that this point here is corresponding to that, so this one is the reflection of this point, this one is the reflection of this point, and this one is the reflection of this point. You know what I mean? So here, if I count the squares in between these two corresponding points, then that's going to be a point on my reflection line, and I'll do that from all the different corners just to make sure, because the line could be at an angle, it could be vertical, it could be horizontal, so it's not enough to just choose one point and go with that. Okay, this one's fairly obvious though. Right, so from here to here we are 1, 2, 3, 4, 5, 6, 7, 8. So halfway in between that is going to be that point there. Yeah. Up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So halfway is going to be 8 squares across, which is there. These two are going to meet in the middle of that one again. So the y-axis is going to be our line for reflecting there. You can't actually really see that whenever I draw it on top. Okay. So this question had asked us to describe the transformation, so we need to make sure we write it out. So it is a reflection in the line. So now we'll have to think about what this line is actually called. Do you remember last day in this example we had the line x equals 2, and x equals 2 referred to the line that went through 2 on the x-axis. So every single x coordinate on this line is 2. Now let's think about that with this one. So here, every single point on this line has an x coordinate of 0. So this one's going to be the line x equals 0 because it goes down through 0 on the x-axis. So it's a reflection in the line x equals 0. Okay, so that's it for that. Hopefully you get on okay with this stuff. Some people do find it tricky to name the line. But obviously I'm going to be there to help you if you're stuck. Okay, see you next time.